Hello everyone. In today's video, I'm going to talk about entry processors. So entry processor execute the operation on map entries in a distributed way. Let's say you have created a map and you have inserted 100 records and your cluster consists of 10 nodes. So approximately there would be around 10 entries of that map on each of the node. So all the 100 entries of a map would be distributed among the 10 members. Now you want to perform some operation on your map entries. If you iterate all the entries of a map and do the operation on a particular node, so in that case there would be a lot of deserialization and serialization. So there would be an overhead of deserialization and serialization, plus there would be an overhead of network hop, because the the map entries would be present on different nodes, and to get those map entries, the data has to be transferred from all the remote nodes to the local node wherever you are executing your code on the map entry. To avoid this overhead, the concept of entry processor is there in case of Hazelcast. So if you want, let's say in the previous example, if you have 100 records in a map and you want to execute some of the operation on the 100 records of a map, in that case you can create an entry processor and you can write your code, whatever operation you want to perform the entries of a map, you can write that code inside your entry processor, and you can just use one map method that is execute on entries. And what this will do, entry processor would be distributed on all the nodes, on all the 10 nodes. So all the nodes would execute that entry process, whatever code is written inside that entry processor, on their local entries. And then what they will do, they will just collect the local result, and they will send all the remote nodes will send their local result to the caller from where the entry processor was actually called. And at the caller end, when all the data is received, so there the data gets merged and the final result is being shown. This is the major advantage of using entry processor. Advantage is that it executes in parallel and it saves a lot of network hops and serialization deserialization overhead. Basically, you can implement entry processor by either implementing the entry processor interface, or by extending the abstract entry processor class, or there are two other entry processor interfaces like offloadable and read only. But today I'll be writing a program in which I'll implement entry processor interface, and I'll show you how to do that. And one more thing, since a map is a partition data structure, all the entries of a map are partitioned among all the nodes. And also there are some backup and async backup of map as well. So in that case, while you are executing any operation on your map objects, in that case you will have to apply the same logic to the backups as well. So all these things I'm going to show you today. So let's start. First of all, I'll create my own entry processor class. I will implement entry processor in interface, and I'll pass the type, whichever type of keys and values I have to create in a map. So let's say the type is string and integer. And since I'll have to implement the same logic on the backups as well, so I'll have to also implement the entry backup processor interface. I'll simply add the unimplemented method, and now I'll implement. So this process backup method, this is our process method. So first I'll override this process method. I'm creating a simple program in which I'll just increment the age value to 10. After doing some processing on your map entries, if you want to return some value, so in that case you can just write the return statement. I'll just return the age, whatever age I have changed, whatever value I have changed to the existing age value, I will just return this value. So this is the processing that I've done in case of process. Now I'll implement this get backup processor method. So what this method will do, this method is basically to implement which entry processor you want to implement on your backup entries. If you do not want to process your backup entries, in that case you can simply return null. If you want to apply the same entry processor on your backup entries as well, so in that case you can return the object of this entry processor itself. And now I will have to actually override the process backup method also. So here I will have to explicitly write the same logic which I have written in process method. This will again apply the same logic to our backup entries. What we are doing is we are just getting the value of getting the age value, and then we are adding 10, and again we are storing it back to our entry object, and finally we are also returning the age value. So let's just assume that there are three people, and the name of the first person is test1, the name of the second person is test2, and the name of the third person is test3, and their ages are 10, 20 and 30. So what I'll do, what my entry processor will do, our entry processor will just increment the values of their age by 10. So now we have inserted three values in our map. I'll just call entry processor on our map entries, and since our entry processor is returning some value, so we'll have to store it. So entry processor will return map entries, and I'll use the map object and I'll call execute on entries. There are other methods as well to apply entry processor. I'm going to use the first method, that is execute on entries. The second method is also execute on entries, but the second method accepts two parameters, the entry processor object, and the second one is predicate object. So if you want to apply some predicate, you can apply that as well. What is predicate? I'll be covering predicate in upcoming videos. The difference between first and second method is that in first method it only accepts one parameter. In second method you can pass two argument. Similarly, there are two other methods as well, like execute on key. If you want to apply the operation on some particular key itself, so in that case you can just pass the key to which you want to apply the entry processor, and you can pass the entry processor object. The third one is execute on keys. You can pass the set of keys on which you want to apply your entry processor. So right now I'm going to use our first method, execute on entries. I want to apply my entry processor on all my entries. The return type of the entry processor would be, the key would be of type string, but the value would be of type object. So we will have to change the type, since here you can see that the return type is of type object, and we are returning only the value, that is the age. So we will have to change the type to object. So this is how I'll call the entry processor. Now since the entry processor will do the updation on the map entries, all the map entries, so what I will do now, I'll just print the value and see if the values has been updated or not. So this will show the new values. Now let's run this program. So our entry processor has been executed, and you can see the result. The value of test1 is 20, the value of test2 is 30, and the value of test3 is 40. So you can see that all the values has been incremented by 10 by the entry processor. So right now I have just created one instance in our Hazelcast program. So all the map entries would be present in on one node. So whenever you create a cluster by using Hazelcast, so there are multiple nodes, and all the nodes consists of some data. So that is a distributed environment. This is one of the major advantage of Hazelcast, is it it provides some of the distributed data structures as well, like this IMAP, which is provided by Hazelcast, is a distributed implementation of concurrent hash map. Similarly, there are other data structures provided in Hazelcast, that is queue, set, lists. So all those data structures are distributed data structure. Some of them are partitioned, some of them are replicated. Whenever you go through the documentation of Hazelcast, in that case you will get all the theoretical information about the various data structures and various concepts. So in my video I'll try to cover most of the important theoretical concepts, and then I'll mostly be focusing on covering the implementation part. But still, if you are facing any issue in understanding any of the theoretical concept, so in that case just let me know in the comment section, and I'll try to make a video on that particular topic. In our normal Java program, if we have to make operations on our map entries, we can simply iterate the map entries and execute and perform the operation. In Hazelcast also we can do the same thing, but in that case the the Hazelcast has to get all the values from all the remote nodes, and then it will have to deserialize it, and then again after making the updations it will have to serialize it and store the value again to the local to the remote nodes. So that is a problem. So just to make it efficient, make the updations efficient, we can use entry processor. And also entry processor executes on partition thread. So what is partition thread? Partition thread, basically when you create a node, there are 271 partitions created in that node. The memory is divided into 271 partitions, and that is the default count. If you want to change that count, you can change that as well, but by default the count is 271. So for every so for every one or more than one partition, there is one thread. So that thread takes care of that partition. So whatever updation has to be made on that partition, so that partition thread only will execute that operation on that partition thread. So that is the thing. If you want to learn more about partition thread, you can go through the Hazelcast documentation, or if you want, and if you are not able to understand that, just let me know in the comments. Also, since uh, entry processor executes on partition thread, and partition thread takes care of the entire one or more than one partitions. So in that case, if you apply very huge and time taking logic in a entry processor, in that case the entry processor is going to take a lot of time, and till the time that entry processor is being executed on the partition thread, till then no any other operation would be executed by that entry processor. So basically that entry processor would be blocked, and all the other operations would be blocked. So it is basically recommended that you apply simple logic. Like in this case, we are just incrementing the value of age. So that this is very simple, but it's just recommended that you try to keep the logic inside the entry processor as simple as possible, so that the execution time of the entry processor should not be very much. So that's the thing. And but to overcome these limitations, there are other two types of entry processor, like offloadable and read only. So I'll be covering all these entry processor in our next videos. So if you want to understand those, you can just watch on my next videos. So this is the topic that I want to cover today. I hope we all are clear on this topic. If you have any doubt, just let me know in the comment section, and I'll let you know, and I'll try to explain that as well. uh, thanks for watching. Have a good day. Bye.